Morning. Today we will see little bit practical analysis of simple salt. Simple salt means that contains one acid radical and one basic radical, or we can say one cation, one anion. For example, you are supplied with a salt. Salt contains two parts, positive parts, that is Ni2+, then SO4. Now, this is basic radical and this is the acid radical. First portion, organic portion, that is basic radical, and then the other one is the acid. Nickel sulfate, that nickel sulfate has got a green color, emerald green color, like this. The board that you see, the color of the board, or you can say this color of this duster, emerald green color. So that has got a color. First we write the heading analysis of simple salt. Previously, board used to give a mixture of salts, two salts. From the mixture, means two salts are mixed, and from that mixture you have to identify two cations and two anions, or two basic radicals and two acid radicals. Nowadays, only one basic radical and one acid. You know that we put three columns. Last year you wrote in your copy, no, the scheme for analysis. You have written, no, color and appearance like. So three columns. We do it systematically, systematic analysis. So step by step we view inference. Experiment, observation. Our first experiment, that is number 1, color and appearance. Color and appearance. Now I told you I have given you a green salt, crystalline salt it is. Green crystalline salt it is. From this color, emerald green. This color, emerald green. So we'll be writing color green. Green crystalline. Green crystalline. So we have a doubt. If it is green, maybe Ni2 plus, maybe Ni2 plus, or it may be copper carbonate. Copper carbonate is also greenish color. So we doubt. So here, copper carbonate on the copper vessels, after long time you see some greenish coating. We say copper is getting spoiled. This color greenish coating you see on the copper vessels. Old copper coins, you see those old copper coins, there will be a greenish coating here and there you see. That is this copper salt. Copper sulfate is blue in color, but copper carbonate is this green. It is powdery green, dull type. Green crystalline. So maybe Ni2 plus or CuCO3. So it's only a doubt first. Maybe Ni2 plus or CuCO3. You can write Cu2 plus or Fe2 plus is also green in color. But Fe2 plus green in color is very light green, sea green, very light green. So this is the way to start. So you are supplied with an unknown salt. Emerald green, sure it is Ni2 plus. Crystalline, and it is Ni2 plus. This is amorphous, powdery, dull. This is again crystalline. It's very light. Still, we are writing all this greenish color once we are writing. Cu2 plus if I write copper sulfate, normally we see copper sulfate. The line. So coloring appears. This way we are starting. Next, what you check is solubility. Crystalline, then it will be soluble in water. So number 2, solubility. Solubility in water. Solubility in water. Only water soluble salts will be like solubility in water, in dilute HCl, in dilute HNO3. Higher classes you have solubility in these three things. But for class 12, only soluble salts should be. So copper carbonate will not be given to you because soluble in water. So solubility in water, we are writing possibilities over here. Solubility in water. So little bit of salt you take, little bit of salt, huge amount of salt you take, and in a test tube, take this much amount of water and add a little bit of salt, huge amount of salt, using a spatula. Spatula means a spoon like this, you must have seen. Like this one spoon you must have seen uh, in our laboratory. So using this spatula of this given salt, water, and shake it well. Shake it well. If it is completely soluble, then we write soluble in water. Soluble. To check the solubility, you should take more amount of water and less amount of salt. Don't take this much amount of water and 5 spoons of this thing. Be looking insoluble because saturated solution. Then again that salt we added cannot go into the solvent. Checking the solubility, take more and less amount of soluble in water. So any soluble salt right here. Any soluble maybe nitrates. Nitrates are very much soluble in maybe nitrates. Nitrates. Nitrates are soluble in water. So we doubtful. Okay. But I told you what I gave you is nickel sulfate. Sulfates are also soluble, but nitrates are very much soluble. Not much flavorless. flame test. For that, you have to write the procedure or how you are doing the flame. How do you do the flame test? Take a watch glass. Watch glass is like this one. This is a watch glass. This is a watch glass. In this, a little bit of this is a watch glass. In this, you take a pinch amount of the given salt and add 1 drop of concentrated HCl. See, I gave you nickel sulfate, so we are changing it to nickel chloride. Chlorides are highly volatile. Chlorides are highly volatile. So when you show this paste, we are going to make a paste with 1 drop of concentrated HCl. And when you show this paste at the non-luminous part of the flame, it will be easily catching fire. So, suppose you burn this wood, what is catching fire? The chemical compound what is present in this wood vaporizes, that vapor is catching fire. Vapor is the flame. Flame is due to that vapor. Or when it catches fire, you see the flame. So we are converting that salt in the form of nickel sulfate. You are supplied with the nickel sulfate, that greenish, green crystalline, The green leaf color green is emerald green. So you see green small crystals. So you take a huge amount of this nickel sulfate. Now I am telling nickel sulfate, you don't know for you it is an unknown, and add 1 drop of concentrated. Using a glass rod, you can make it into a paste, and using the same glass rod, you can take a little bit of that paste and show at the non as part of the flame is blue color flame. So we'll be writing that pinch amount of the soap and 1 drop of 1 drop of concentrated HCl added and made into paste. Using the glass rod, take a little bit of the paste and show at the non part of the flame. Take a little bit of paste of the paste and show at the non-luminous part of the flame. So at the non-luminous flame. Non-luminous flame is blue color flame. If it is yellow color flame, means carbon particles are catching fire. When carbon particles are present, you get yellow flame. We call it as sooty flame. S-O-O-S-O-O-T-Y, sooty flame. Non-luminous flame means blue color flame. That is a clean flame. Non-luminous part of the flame. So you observe, is there any color imparted to the film? You know that if it is apple green color, Pa2 plus. If it is apple green color, Pa2 plus. If it is brick red color, Ca2 plus. If it is crimson color, then Sr2 plus. So here, it is nickel. Okay. You know it is nickel, so you will not get any. So no characteristic. No characteristic color. So we write absence of A2 plus, A2 plus, and Sr2 plus, and Sr2 plus. So preliminary experiment is over. One more thing you can check whether it contains ammonia or so first is color and appearance, second is solubility, third is flame test, and fourth is action with fourth is action with action with. If you smell the test tube, the mouth of the test tube, do not touch your nose on the test tube. Just bring it closer to your nose. You are getting the smell of ammonia. That means your basic radical is NH4 plus. So here, nothing, Ni2 plus it is so not NH4 plus. So I write no smell of. If you get the smell of ammonia, you write smell of ammonia presence of maybe NH4 plus. Now here, no smell of ammonia, so we write absence of absence of NH4. That portion is over. So the preliminary experiments are over. So preliminary experiments, we used to give Roman numeral number 1 for preliminary experiments. In that, Hindu-Arabic normal 1, that is color and appearance. That last year also you did. Number 2, that is, now we are moving to preliminary experiments. Now we are moving to systematic analysis of acid radical. Systematic analysis of acid. So this is the heading. Heading you can write from the left to right. Heading you can write from left to right till it goes. Now number 5. Or you can write number 1. Number 5. First we are doing with the dilute H2SO4 test. In that you are going to catch hold of 4 acid radicals. If no observation is obtained in that case with the dilute H2SO, then we will be moving to concentrated H2SO. So first is with the dilute H2SO4, you are trying to catch 4 acid radicals. If you are not getting any observation, then we will be treating with concentrated H2SO. There you will be getting 5 acid radical. 5 acid radical. So if you are getting with a dilute H2SO4, then you don't have to go to concentrated H2SO4. If you are getting any observation with a dilute H2SO4, then do its confirmatory test and finish it off. If you are not getting with the dilute H2SO4, then you have to go to concentrated H2SO4 you are getting 1 from there, do its confirmatory test. So first we are doing with dilute H2SO. Number 5, action with dilute H2SO. Dilute H2SO. So what you are doing, you are simply taking little bit of salt and add dilute H2SO. Dilute H2SO. So the moment you add dilute H2SO4, you are expecting four different types. From that only one you may be getting or nothing you may be getting. If the brisk efflorescence is coming, then it is carbonate. If the smell of rotten egg is coming, that also like bubbles or gas type coming, then sulfide. If a gas is coming, that turns potassium dichromate paper green. Then sulfite. Suppose a reddish brown vapors are coming. Then it is nitrites. Then one more you can say, you take pinch amount of salt in a watch glass and add 1 drop of dilute H2SO4 and rub it with your these 2 fingers and smell it. And if you are getting a vinegar-like smell, then it is acidic. So these many, by adding dilute H2SO4, you expect 4. By rubbing with dilute H2SO4, you expect acetate. That is 1. So ours is sulfate. Sulfate is not coming in this. So by adding dilute H2SO4, these observations you are not going to get. I told you by rubbing with dilute H2SO4, by adding this dilute H2SO4, if you are getting that smell, then you can doubt for acetate, vinegar-like smell. So then we are going to see action with the dilute H2SO4. So here RC sulfate, nickel sulfate, emerald green. So you will not get any observation here. Right. No characteristic observation. So we write absence of what are just no crystal persons, so CO3 minus absence. No rotten X1, so X2 minus absence. No reddish brown vapors or no gas that turns potassium dichromate paper green minus absence. Para SO4 minus SO3 2 minus sulfide. Then no reddish brown vapors, so okay. No vinegar-like smell, so acid. That's it. So we are going to concentrated H2SO. Concentrated H2SO4. After adding concentrated H2SO4, you have to warm testing. You have to warm the testing. So concentrated H2SO4 you are adding. There you are expecting what all things? Chloride, bromide, iodide, nitrate, and oxalate. But our sulfate, in that also we are not seeing our sulfate. That means we are not going to any observations in this category. So next is what? Action with concentrated H2SO4. Concentrated H2SO4. you are adding and heating. If you are getting a gas is coming, a vapor, a slight white color vapor, slight white color gas is coming. So if it is coming, what do? You dip a glass rod in ammonium hydroxide and show at the mouth of the test tube. And if that light gas becomes dense white fumes, then Cl minus is present. Instead of that gas, what was coming? If it is reddish brown vapors, then bromide. Suppose that is also not there. Suppose violet vapors are coming, that means I minus is present. Suppose some gas is coming, but we cannot make out with a glass rod dipped in ammonium hydroxide, nothing, no reddish brown, no violet vapors. Then what do? You add a paper ball to that. If then the reddish brown vapors are coming, then it is nitrate. Suppose means you are heating the test tube, you removed that test tube from the flame, still some bubbles are coming. That means Mariska force is coming. That means oxalate is present. These things will be seen in the next class. Thank you.